So we are live on YouTube as well as on Zoom. Good evening, participants. Welcome to the live session for the course Classical Mechanics 1. Our instructor, Professor Bhabani Prasad Mandal sir, is with us along with our TA. So you can join Zoom directly and interact with sir related to the subject. Those who have very less bandwidth can watch the event on YouTube, and you can post your queries on the YouTube chat. We will answer it. Thank you. So let's wait for the students to join in, sir. Yes, sir. You're muted, sir.
Sure, we'll wait for the student.
Right, sir. Thank you, sir. So let's wait for 5 minutes, sir. I just checked the YouTube streaming. Nobody is watching there also. So let's wait for 5 minutes, sir. Yeah, you're muted, sir.
Yeah, sure, we can wait for the student. Yeah.
Right, sir. And this session is getting recorded, sir. Just in case if nobody is joining in, you can also discuss something in general so that the students can watch later also, sir.
Okay.
Just in case if you want to discuss something in general related to the subject or how to prepare for the examination, those kinds of things you can share with our participants, sir. Thank you, sir. So again, I checked on the YouTube. Nobody joined over there. Would you like
Okay.
to review the forum query, sir? I will just share the screen. You can just,
Yeah, sure.
sure, sir. I'll just do that, sir. So these are all the queries posted on the discussion forum. Most of the queries are already replied. Would you like to, uh, which one should I click and,
Yeah, that I don't know. This
okay,
maybe um uh, maybe is the this one second. Yeah,
is the
this I have.
function? Yeah, I'll
Yeah.
just click, sir.
The question was I have question about this. Where is the question?
This is the question, sir. Sir, you have considered the functional as a function of y dot and x and treated it as Lagrangian function, which is a completely different function of q dot and t. Is this justified? And then you have mentioned that you did not understand that particular question, whether it is
Okay.
functional. Yeah.
Okay.
And
Yeah,
then
then he replied, yeah,
he
I
replied it.
mean, yeah, first part of the Hamiltonian principle, you define Lagrangian and use a functional with the second part, the Euler Lagrangian equation. Okay, so after that, is there any reply from me? No?
No, sir. For this query, there is no reply, sir.
Okay. So maybe let me clarify this issue. I think the student Anmol Shaw is asking about the functional which I used for y dot and x, and later I use as a, to derive the Euler Lagrangian equation. I use a Lagrangian function which is a function of q dot. So first with the example, if a general functional is a function of function, which I consider general y and y dot means dy dx, and x is a general, and try to describe the variational principle there. And that variational principle result we use for the Lagrangian. So Lagrangian is similar, exactly similar functional like q dot and t, like your y dot and x. So y is analogous to q, y dot is analogous to q dot, and x is analogous to t. So exactly same result we use to derive the consequence of Hamilton's principle, and that leads to the Euler Lagrangian equation. I think this clarifies this issues.
Thank you, sir,
Yeah.
for replying to that particular
Maybe
query.
let me see any other technical questions are there.
Yes, sir.
Uh,
About generalized force. Shall I click on this thing, sir?
yeah, let me see.
Right. I think you already replied, sir, to this.
Yeah. So the question was why we call generalized force. What is the difference between force of generalized? Definition of generalized force is given in the lecture. Generalized force, we can have any dimension. Okay. So like the coordinate, as I mentioned in the very beginning lectures, that generalized coordinate is not the like the usual coordinate. It may or may not be. So it may have a dimension of length, it may be a dimension less, or it can be any quantity. So when we use the definition of force using those coordinate which has any dimension, naturally the generalized force also will have the any dimension. It will not have the dimension of force only. So generalized force is a general concept for which the normal force is a subset of those generalized force. So it is a concept, generalized force is a concept using generalized coordinate and also normal coordinates. So it can have any dimension. And that is the difference with normal force. I think this also clarifies here.
Thank you, sir, for answering the query on generalized force. Let me go back. So can I click this one? I just started. We don't know what exactly it is. Let me just click.
Okay, no problem. Yeah.
This is a general query, sir. Let's skip it, sir.
Yeah, regarding some, yeah.
Right, sir. Something on virtual displacement, sir. This particular question is not yet, and 1 second, sir. Let me just see. Yeah, it is answered, sir.
Yeah, it's answered, and then yeah. So I think these are questions. I think, yeah, no need to repeat. I think question was the virtual displacement. So virtual displacement and normal displacement. Let me differentiate between these two again. Normal displacement happens in a finite interval of time. So it takes some time, non-zero time interval to happen. That is the real displacement. But if we imagine that displacement occurs without taking any time, instantaneously, then that is called virtual displacement. So you are imagining, we are imagining that situation. So what is the advantage? Advantage of virtual displacement is that it is not taking any time. So nature of force before the displacement, after displacement is same. But for a real displacement, when you have an interval, the nature of force also evolve. And during that interval, force will be different. So then it is difficult to consider that how forces are changing. So the situation. So to remove that difficulties, people postulate this virtual displacement, and things are simpler in that sense. Yeah.
Thank you, sir, for answering the query on virtual displacement. Let me just go back. I'll just click on this query, sir, and see what exactly it
Yeah,
is.
sure. Yeah, this also I had answered.
Yes, sir, you have answered.
Question was that in the problem of a sphere rolling down the inclined plane, I cannot able to get which of the two components of the velocity equation of constant are integrable and which to put in the category non-holonomic constant. It has three generalized coordinates. Okay, so let me read my answer. Constants in this case, vector V equal to omega cross R, cross product between the omega vector and R vector. This is the constant, and this constant is a vector constant. So it will have three components. So three constraints. So number of degrees of freedom will be 6 minus 3. 6 is the total number of degrees of freedom of a rigid body, and 3 is the constant. So number of degrees of freedom is 3. Now, since the sphere has no fixed axis of rolling, you cannot integrate all Vx, Vy, and Vz. Any two. So, your question is that which two? It can be any two. You can integrate Vx, Vy. You can integrate Vx, Vz. You can integrate Vz, Vy, Vz. So, when you perform the two integration, then third integration will be complicated, and it will not able to. So that will be the non-holonomic constant. So, and then this has been discussed in this particular book, Rana and Jog, I mentioned. So the answer to your question that you cannot say which two will be integrated and holonomic constant.
Thank you, sir. I'll just go back. Something on quasi coordinates, sir. I'll just
yeah.
So this is the question. So I didn't understand well about the quasi coordinates. Can you please explain it with some examples? Already you have given the explanation.
Yeah, so let me read out my answer, then I'll explain also. So if there is a non-holonomic constant, as I mentioned in my class, non-holonomic constant is basically a constant which depends on velocity, which cannot be integrated, or there is an inequality. But when there is an inequality, for example, x can be less than x0. But when within x0, it can have a usual motion and you need a coordinate. So if your system has non-holonomic constant, your degrees of freedom will be less, but you will need a coordinate to describe that non-holonomic part also. So those coordinates are known as quasi-generalized coordinate. So, for example, if you have a particle inside a sphere, so particle cannot move beyond the radius of the sphere. So it is confined to the spherical cavity. So, but still to describe those particles, you need coordinates. So those coordinates will be quasi-coordinate. So quasi-coordinate are related to the non-holonomic constants. I think this will clarify that.
Thank you, sir. So next question is on some constraints, sir. I'll just click on that.
What is the major difference between holonomic constant and scleronomic constant? Yeah. So there are two different categories. See, I specifically repeatedly mention in my lecture that all constants are either holonomic or non-holonomic. So there the scleronomic constant will not come. This is one classification. And what are the holonomic, what are the non-holonomic, I define clearly in the class. Now, people can also define constant depending on their time dependence. Okay. So, for example, if some constant depends on time, then that is called deonomic. And if it is independent of time, then it's called scleronomic. So, all the constraint can be defined by scleronomic and deonomic. Deonomic is time-dependent constant, scleronomic is time-independent constant. So this is a completely independent classification. For example, a deonomic constant can be holonomic, it can be non-holonomic also. Similarly, a scleronomic constant can be holonomic and also non-holonomic, because there are two different classifications. And there are also many other classification of constant. In the class, I have discussed 3 different types, but there are many others also.
Thanks, sir, for answering that particular query. I think something on book they are asking, sir.
Yeah.
Sir, Upadhyaya is
not
good or bad for
good.
classical
So in
mechanics?
the class, I mentioned that there are many good books and there are also many bad books also. So I asked the student not to read the bad books, and probably Upadhyay I don't recommend because I found many mistakes in these books. So that is why I put that book by J.C. Upadhyay in the bad book list. So he was asking why it is bad book, because it has many wrong concept and many problems they have solved wrongly. So that is why.
All right, sir. Thank you, sir. So those are the queries basically posted,
Yeah.
which are already replied, sir.
And nobody has joined in the live.
Yes, sir. Nobody joined on the live. Let me just check the YouTube, sir. 1 second, sir. I'll just stop
Yeah.
the screen share. I'll just check the YouTube. No, sir.
Okay. So maybe I'll spend 1 or 2 minutes regarding how to prepare the final exam.
Right.
And then maybe we can close this.
All right, sir. We will do that, sir.
Yeah.
Yes, sir.
Yeah. So the exam is scheduled on 25th of October, both morning and afternoon session, that you already know. And exam also will be MCQ type. So there will be, I think, 50 questions to answer. And questions are well distributed over all the topics, that all the 12-week lectures, all the topics. And nature of the questions will be more or less like assignments question. So if one student understand all the assignment questions, then the exam will not be difficult at all for them. So I suggest the student to prepare or to solve or the assignment problems, those who have not submitted or has not completed the all 10 question in the assignment, please do this. So there will be certain number of questions directly from assignment, certain question will be similar to assignment, and certain will be not like the assignment question, but new questions. So, but those as questions, one has to solve it. It is not like that you can take because it is 3-hour exam, right?
Yes, sir.
Yeah,
The exam
3-hour
duration.
exam and 50 questions. For all question, you have to do some small calculations. So that you have to be, there are questions which you don't have to do calculation, informative type, but many questions are there where you have to do small calculations, analysis, so that this will help you in preparing the exam. So good luck for your exam. And since nobody is there in the live session, so maybe we will close this session.
Sir. Thank you so much, sir, for your valuable time. Thank you, Mr. Gaurav, for joining in. Would you like to say something, Gaurav, before we conclude?
Okay. So no, I have nothing much to say.
So you have any experience or anything, or in this, because this is our first online courses. So if you have any experience or anything, you can share.
Yes, of course, experience was there. Like I'm doing this work as a TA for the first time. So regarding when I have been also following this NPTEL courses during my, during my BSc course, but I was not registered. But yeah, it was a good experience. Like I got to know how it works.
Nice, Gaurav. So with that note,
Yeah.
we will conclude the session.
Yeah. And even the student has queries, questions before the exam, please put in the discussion forum. I'll regularly check, and at least before the exam, I'll answer all queries.
Definitely, sir. Thank you so
Yeah.
much, sir. Thank you so much for your valuable time, sir. Okay, sir, we will end the session now. Thank you, Gaurav, for joining in.
Okay.
Bye, sir.
Okay.
Bye.
Thank you.
Thank you.